took one of the few computer science classes I've taken. I'm studying mechanical engineering, but one of the few computer science classes I've taken for my technical breadth was a class in artificial intelligence. For our project, we were tasked with creating something called an inference engine, which is a little bit difficult for you to grasp if you haven't studied AI yet. But I have a buddy who has absolutely no computer science experience, and one day back in February, I broke inference engines down to him, and he was able to understand it. So let's see if I can replicate this effort. So the basic premise of an inference engine is that you have a set of rules and a knowledge base that grows as you apply rules. A rule will look like this. No, it's cool. A rule is really simple. If P, then Q. You have a premise and a conclusion. P is the premise. When it is fulfilled, then Q becomes true, and Q is then added to the knowledge base. An example rule would be, my friend likes to eat a lot, so
if it's the lemon.
It's doing German autocorrection.
I think I'm just on the screen and highlight it.
Yeah.
yeah, or like a different keyboard.
You can highlight the forum post, can't you?
I can just load the forum post right now and you guys can read it. Wait,
Especially on
there we go.
German keyboard.
It's GS 2012.
Page 6. Or actually, that's what Tops quotes you.
Oh, okay.
Different page.
There we go.
Yeah.
I'm gonna find it.
So you crank P or
Post 48.
Okay, cool. We're at 42. We're getting there.
Hey.
Babble about technology, just spewing random facts that are completely over someone else's head. Okay, I do that often. And a little bit of syntax in here is kind of specific to Heimdall. If you look through the source code, like movie, bracket, genre, you kind of have a better understanding, but you get the idea. Right here, the best explanation sentence.
Where it is lemon, it's yellow.
We were arguing about, so one confusing fact was inference engine they use rules, and someone said, how do you determine the priority of a rule? Which rule should take precedence if both have fulfilled premises? The problem is that you can't attach a priority to a rule because once a rule has been established, it is assumed to be I think the word is tautology, it's always true. There's no sense of priority. If you have two different conclusions from the same premises, then either both must be true or neither are decidable. Another way of saying it is if you have conflicting rules, you can't prioritize one conflicting rules are essentially not allowed in the knowledge base. Once you add 2 conflicting rules to the knowledge base, you've just basically shot yourself in the foot.
Is there a difference between trained and all the other forms of AI?
What's that?
Trained and all the other forms of AI?
No.
Can you apply weights to the knowledge base? So each knowledge has a weight that keeps propagating to 3 every time that knowledge is used to infer another rule.
And then the weights would be used to resolve any sort of conflicts.
Yeah.
Yeah, there are several conflict resolution algorithms for knowledge bases. This is if you have a knowledge base and you're trying to decide across incomplete information, and you might get conflicts. There's several resolution algorithms. One is weighting it. Another, which is really simply implemented, just use the most recent conclusion. If you derive a fact, or if you derive 2 facts that conflict, the one that you most recently derived is the one that you stick with. Another algorithm is called Occam's razor. I don't know if anyone's ever heard of Occam's razor, but it's basically the principle is that the rule that you derive with the fewest steps is the one that's most likely to be true.
Right. Occam's razor basically says there are several explanations for something that's happening. The easiest is true.
Yeah.
Because
Well, and it makes sense if
you can use it like for politics. Like
exactly.
you can use it for everything. It's just a basic premise.
The more complicated it is, the more flaws could be present. So it makes sense to just use the most basic of the multiple ones. A consistency enforcer was the conflict resolution algorithm that I was talking about.
Is there good outcomes in Wikipedia? Or is it so?
I didn't go to class that often. Most of this information I picked up from Wikipedia. But there's a really good textbook on this kind of stuff. I haven't read that.
So how are you doing the game stuff at the moment to pass stuff to Heimdall?
We're not passing anything to
Okay.
Heimdall. It's its own application. We haven't integrated it into XBMC.
Right.
Invoking Heimdall is as simple as giving it a unique identifier. What would it be called? A subject. You give it a subject like C:/MarioBrothers.smc. That becomes the subject. Then Heimdall starts inferring conclusions based on that subject. I think here's an example right here. If the subject has a file name, if you know the file name of a subject, then the title becomes that file name minus the extension. Simple rule. It can be applied to all file names. That's what we do for movies. The title of the movie, we assume that it's the movie minus the extension and a couple other little details in the rule. Once you have the title, you can have a rule that says if X is the title, then all this other information can be derived by querying TMDB using that title. And you apply little rules like that. So rules in Heimdall aren't necessarily as simple as if it's 11 then it's yellow. They're basically Python scripts, where you have an input and an output, like Tobias was saying on his little presentation. And it might be the case that TMDB isn't able to provide information, like say it can only do a search. So you give it a movie name called Fight Club, and it's only able to return search results that contain a name and a year. So Fight Club in 2002. We could have another scraper site that requires a year. It wouldn't be able to run with just the name, but once Heimdall applies the TMDB rule to that name and obtains the year, it's then able to use both of those, both of those entries in the knowledge base to propagate forward and continue applying rules. and basically it keeps on applying rules until either all the information is known or there's no other rules that can be run. Which
The thing we feel on now with current scrapers is that the year on the IMDb and the movie database differ by 1 year. That's on how they release it, so can we...
yeah, the rules are Python scripts, so simply try this movie
Also,
this
also
year.
minus one.
If it doesn't work, add one and subtract one. But TMPB actually has a new search API that handles that pretty well.
Yeah, but even if you're on IMDb, if you're this 2013, and the user has 2013, it won't find the movie in the movie database.
Yes,
It needs to be 2012.
so that would become a Python rule.
Yeah.
Just instead of an if p then q statement, it becomes a script that tries multiple queries, sees which one,
So for you,
which one returns a result, and then selects the base one based on that result. Either some sort of general selection algorithm, or we could implement machine learning using a corpus and all that fun stuff.
So what about like scene releases for TV series where the file name has nothing to do with the name of the series?
Then you need to draw information from other areas, maybe the length of the movie or certain information embedded in the MKV file that kind of defines the movie. If there's no,
Not done though. They usually don't embed the MKV tags.
so
Now you need to read the NFO file that came with it and then start searching again.
so here's the general principle. Here's the general principle. Tobias and I were talking about the overarching rule: don't ignore data. In a machine learning algorithm, any data that you can put into the system can be used to increase the probability that the output is, or it increases your certainty in the output.
Right.
So let's say you have a file called fightclub.avi and it's only 5 minutes long. The certainty that that file is the movie Fight Club could be relatively low if you consider the file time. If you have a scene release with no file name, but you know other properties about it, then you can use those properties to basically increase your certainty in whatever result you're striving toward. If that makes sense.
Do you have to tell it that you're looking for a movie, or is there a way to just throw it a file name and it
But the length of the file.
kind of...
You know, it's 1.5 hours, so that's not going to be...
Yeah, so,
probably.
yeah. So it can take basically a whole seat of data about that.
But it could also be a very long music track, or I don't
Yeah.
know.
Yeah, but then you can't find it.
So
you're
you
gonna
give
say,
them no
okay,
info.
it's not a movie, so let's make the TV show or
As
something
far
else.
as I understood from reading all of this, because I read all the thread,
Or not.
yeah, well, I thought it was interesting. As far as I understand, if this would work, like be finished completely, top of us said you could just take a folder, throw whatever you want in it, movies, TV episodes, even ROMs now, everything we have, and it would just find it, scrape it, organize it, and you get a neon library. Which to me sounds like...
And it essentially is, and that's what AI can bring to the table. This sense of magic where it learns as it goes and becomes really smart to the point where input is no longer necessary. You'll no longer need to set a particular scraper for it because Heimdall can pull from as many scrapers as it needs. You'll no longer need to specify. Yeah, exactly. Everything becomes Python scripts, which are rules. You no longer need to specify whether it's a TV show or a movie, because Heimdall can use all available information. Perhaps the encoding of the movie can give a little bit of a hint, the file or the length of the movie, to guess whether it's a TV show or movie. I actually broke down the math in here at one thing.
The problem with AI is that it kind of scales ambiguously. So you could have significant performance issues.
Exactly, yeah. So, yeah, here's basic base theorem using the length of the AVI file to guess whether it is a movie or a TV show. And not only do you get, you basically get a relative certainty, a probability of it being a movie or a TV show. And the math is right there.
The posterior possibly. Yeah, you'll still
Sure.
have maybe like a double
Yeah,
episode.
but just have the math major explain this.
What if,
for the applicants.
Right.
no, I thought you were.
Oh, no. I
Just-
only
just-
I'm happy to explain base there, I mean, want me to.
No, but if I understand correctly, like if Heimdall would calculate the possibility that like, is that what would happen? I have a file, it's 42 minutes, well the probability of it being a TV show is very high, so that would just mean it would try to find it as a TV show first, right?
Right.
If it wouldn't find it, it would then consider the possibility that it was in fact not a TV show.
Yeah.
So
Except it actually does both at the same time.
yeah.
Or in parallel.
Exactly.
It should happen in parallel, and the one with the highest priority, once the priorities separate, or
Exactly.
probability separate a certain distance, you can throw one away.
So
Right.
the math right here, I gave an example.
There must be an example.
So here's an example. We sample 100 movies, and we find that the average length of a movie is 2 hours, with a standard deviation, assuming a bell curve. The average length of a TV show is 30 minutes, which is pretty typical, maybe 20 minutes or so, with plus or minus 10 minutes. You can apply this formula up here, and you get the probability of a 30-minute movie or a 30-minute AVI file being a movie is 2.38% probability, which means that the probability of it being a TV show is 97-point-something%, just by applying Bayes' theorem. And the data that you get from sampling, you don't even have to sample your own library. You could just do random queries on TMDB to get this information.
Yeah. So essentially you're combining the prior information. So this formula here, the P movie is your prior probability before you observe your data that something is a movie. Okay, so you've got a file name, you don't know anything about it at all. What's the probability that it might be a movie? So maybe we don't know. So we just say 50%. It's either a movie or a show. And then you update that based on the information you know. So given that you know the time, what's the probability that it's a movie? That's what you want to know, right? You know the time, what's the probability that it's a movie? Unfortunately, what you actually have is if it's a movie, then I know what the times are going to be, right? Because most movies are about 2 hours.
Yeah.
And given it's a TV show, I kind of have some information about the time, because most TV shows are either 20 minutes or 40 minutes. Okay, so it's kind of backwards, and Bayes' theorem allows you to reverse that. That's all it comes down to.
I know that math, I've seen it, scared a lot of computer science majors, but it's really powerful,
Yeah.
and
And you can extend it arbitrarily, so so once you get other information in, then, because, so based on this, right, there's a 2.38% chance that it's a movie. But in addition to this, we go out and we search on tmdb.com, and it doesn't return any hits. Therefore, the chance that it's a movie's gone down even further, right? Whereas we searched on the tvdb.com, and it did give us a hit, so now we're much more likely to be a TV show. So essentially, you eventually get almost 100% certainty.
But doesn't that approach generate a lot of traffic on the subscriber side?
a lot of what?
Potentially.
Oh, yeah, definitely.
Because it asks there, and then it fails.
But to be fair, we're kind of doing that anyway.
Yes, but it might be a bit worse than that. Well,
It could be better.
No.
Well, I mean, people
It's always
keep
gonna be-
running scrapes and
Oh, right.
scrapes trying to correct it.
Right. Yeah.
If we're concerned about traffic, I think the solution is to simply prioritize the order of the Bayes' theorem applications. So if you want to rely on whether or not a particular movie returns positive on a website, simply apply that last if the probability is still relatively uncertain. If there's maybe a 1% chance of it not being what you think, then search the web. If there's a 0.0001%, you probably don't need to run the query on TMDB. And you can do that as a function of what your current percentage is. So it might be the case where we even generate less traffic. If we make this really smart, that can happen.
okay.
Awesome. Could this eventually become sentient?
The first thing is Sky.
It's going to start watching movies for us.
Yeah.
It was a good TV show.
You
You would have enjoyed it.
You would enjoy
this. Thank you.
Yeah. Then after you, I think Rick probably.
Yeah. Awesome.
Basically, this is the first round of breakout sessions.
Yeah.
After start binary add-ons.
Basically, yeah. I'll just find
We still have, we essentially have lunch tomorrow is all whatever we're home on. And I'm thinking we should make two, one outside in front of the tree in the courtyard looking on the house, and then one in the bar.
Ooh, look at all those slides. They look all fancy too.
Oh, wow.
Oh, right, yeah.
It really does nothing at all.
It's like download this thing.
Does that green light open?
I can't even do that.